everyone. My name is Oya Demiblek and I'm a professor of industrial design at UNSW. And on behalf of the industrial design program, I would like to extend a warm welcome to all of you joining us today. I welcome you from the beautiful Bijikul country where I live and acknowledge the Bijikul people who are the traditional custodians of this land. I would also like to pay my respects to elders, both past and present, and extend that respect to all other indigenous people joining us today. So when I checked this morning, we had 160 attendees in LinkedIn, and hopefully they will realize they need to click and register. And many of our guests are from overseas, and we're very excited about that. So welcome, and thank you for joining us for our first talk of the year for stories behind products. So we are expecting these talks to be quite fluid. The audience can ask questions via the chat and we'll get to all of them at the end of the presentation. Today, we are proud to have Nicholas McColl, an industrial designer living in Australia and working at Breville. Welcome, Nicholas. Nicholas is the principal industrial designer at Breville, an Australian publicly listed company with a group of global subsidiaries leading small electrical appliances in the consumer products industry. Before joining Breville in 2013, Nicholas was the co-founder of Transportable Spaces. And before that, he worked at as a creative director at Plus Creatives, a multidisciplinary design studio, again co-founded in 2004. So today, Nicholas will talk about the story of Creatista Plus coffee machine, an Nespresso portion coffee machine with an advanced microphone technology. So over to you, Nicholas.
Okay, thank you. If I can share my screen. Okay, so I guess this project, although I'm presenting it, it had a really very large back end to it. I was, for the time I was at Breville, starting in 2013, the lead designer on the project, and I also worked in partnership with a lead engineer, and there were also many other designers and engineers and other disciplines within the business working as backstops to us due to the complexity of the project. So I think this project really started as a story about milk and how at Breville we've been working with milk for about the last 12, 14 years. And that is a key innovation that we have, which is automated micro foam milk, which is the sort of milk that is used in third wave coffee. And it's a very specific fluidity or viscosity, which allows you to pour it and create repeatable, consistent flavors in your beverage, as well as latte art, which serves two purposes, which I'll get into as I move along. So a barista manually foams milk, and that's through the process of starting with cold milk, and a quantity of that is added into a jug. The steam tip is then dipped into the milk, but not completely. So when the steam is activated, it creates a venturi around the skin of the steam tip. And in doing that, it then draws air down into the milk. And that air, when it hits the milk, creates the bubbles. The steam itself doesn't create the bubbles. It just creates a motive force to create that vacuum. It also spins the milk if the steam wand is positioned in the right way. And as that milk spins and as the bubbles are created by the cold air, every time the bubbly milk passes that steam wand, that steam smashes those bubbles down to a smaller and smaller size. and the spinning motion integrates and homogenizes that air into the milk. Now, that's known as stretching, and that process you can do from the very beginning right up until you've reached your desired temperature. Although if you do it that way, you'll typically end up with large soapy bubbles because it hasn't had time to crunch those bubbles down. So the way that we do it is introducing the air until the milk gets to about body temperature, which is, you know, 30, somewhere between 30 and 40 degrees. So you just use your hand to feel that temperature. And then once you reach that temperature, you submerge the steam tip into the milk. And you just use the steam to create that vortex. And that mixes and mixes and mixes. And then you allow the milk to reach the temperature that you want, which I think typically about 65 degrees is considered the best possible temperature, where it's easy to drink, it won't burn your mouth, and it brings out the best flavors in your coffee. So that's done manually. And it's surprising how difficult it is the first time you do it. It is a skill. What we wanted to do and what was achieved in beginning, I think back in about 2010, it was before I was with Breville, is an automatic coffee machine, which is the BS 980, otherwise known as the Oracle. And that had our first generation milk frother. So that's kind of where everything began for this project, although I don't think knowing that it was going to become this project. Now, there have been milk technologies prior to ours, and one that is very popular with a lot of machines is, again, it's some sort of heating device that creates steam, and that steam is then forced through a venturi. And it has two inlets into the vacuum side of the venturi. One is connected to a milk reservoir, the other one is connected to an air inlet. And that venturi sucks milk into the deceleration zone of the venturi, and it mixes it with the air, and that creates, again, textured milk. But this system has a little bit of a downside, and that is it's difficult to clean, and after every use you need to purge it. So you need to run water through it, and that means emptying the milk out of the container and putting water into the container. And then after multiple uses, maybe a couple of days, you need to strip the whole thing down to its component parts and wash them. Otherwise, the milk starts to get somewhat smelly. So we wanted to design a machine that avoided all of that sort of messing around, I suppose, is one way to put it. Another aspect of that milk foam is it floats to the top. It's not integrated into the milk. And it has a very dry texture. So it's very much like meringue. It will hold its own form if you scoop it out. Now, it's suitable for a latte macchiato. Now, that is a drink that Nespresso traditionally have served through their machines, and they have some machines with this particular milk frothing technology, and it's proved to be popular. But in Australia, and when this project started, increasingly in the United States, this sort of milk foam was not really acceptable for home coffee use, because people were obviously buying much more sort of sophisticated coffee drinks at cafes nearby. So cafe latte, flat whites with a very different sort of milk texture. And this is what we wanted to do with our machine. So milk suitable for latte art. It has the consistency of wet paint when you pour it. And as you pour it into the milk, you can start moving the cup around, moving the jug around, and you can create these amazing designs. The other part of this visual aspect is the taste. And the goal when creating this sort of rosette, like in the image on the right, is to create an unbroken ring of crema, coffee crema, and milk. And what that means is that very first sip that you have, those little tiny air bubbles are coated in the coffee oil, and that makes the the taste sweeter, and it sort of pops on your tongue. So you get an instant sort of assault of beautiful, strong coffee flavour. So we needed to make a machine that made this coffee. And what we did with the Oracle, the BES 980, is we built a boiler system for that. Again, that was driving a Venturi, but instead of the Venturi sucking milk in, we had it connected to a one-way valve to stop any liquid reversing up that when the machine was cooling down. But we had an air pump at the other end, except the air pump this time was not working as a pump. We needed to precisely control the amount of air that went down that steam line. So the air pump is used more as a regulator to control the flow of fresh air entering into the steam. To kind of give an example of the sort of ratio, it's anywhere between 1 part air to 200 parts steam to 1 part air to 400 parts steam. So that's the sort of very finely tuned balance that we needed to achieve. So this is a good little example of the previous style or the earlier type of milk frothers running back to back with what we could achieve with the Oracle. So on the left is the old style, and you can see it comes out in blobs. And then on the right, you can see the milk float quite quickly. Not as fast as water, like what I've said before, wet paint. Now, the images down the bottom are typically the sorts of foam you'll get out of this older style of milk frother. The image on the right is the milk foam that went through the funnel on the right-hand side. I'll just play it again, just in case you missed it. But on the right, you'll see a nice clean flow, and it empties the funnel almost entirely. The only foam that doesn't come down is stuck to the sides of the funnel. But on the image, the small movie on the right, just start from the beginning, you can see it comes out in clumps, and then it more or less stops. And from around about this point onwards, the only reason it continues to drip is that foam is starting to break down. The bubbles pop and the milk becomes liquid again. So we thought we had a pretty good system, and it went into the 980. And I think that machine was launched, if not prior to me starting at Breville in 2013, around about the time that I did start. So we got that out into the wild for the public to see about the time of that I came into the Creatista project. Although it is worth saying that this project predates my involvement in Breville, because a couple of years prior, Breville was looking at entering into a machine partnership with Breville. So what that meant was we would sell Breville machines and they would be co-branded with both Breville and Nespresso. And it's similar to DeLonghi. They have similar machines that are co-branded between DeLonghi and Nespresso. But what DeLonghi also had is they had their own machine that created textured milk. And it seemed natural that we had this really great milk technology. And we had started this machine partnership with Breville. So it seemed like a really good idea. Why don't we pitch to Nespresso a cafe quality microfoam milk possibility to work with their coffee machines? So the guys who were on the project then, they started thinking about what would this machine look like? Should it be an integrated machine where you have coffee and steam built into the same machine? Or could it be a standalone milk frother that sat next to the Nespresso machine? It went through many iterations and looking at the design language of Breville, the design language of Nespresso, and how those two things can be married together. And as it progressed, for the purpose of the first demonstration model, it was decided that we should build something that looks like the Nespresso U machine, and could sit next to that machine, and it would be a paired component with Nespresso. So on one of the annual meetings when Nespresso were in Australia, to talk about the other machine sharing component, a prototype was put together and displayed and driven for the team from Nespresso, and it worked fantastically. Nespresso were pretty impressed with what we could do. They didn't catch on to our tiny little secret, even though it was driven as the functionality sort of was designed to do, so creating steam through a venturi and then through the steam wine and frothing the milk. My understanding is we didn't fully have PCBs, etc., to drive it. It had to be driven using standard sort of components from another machine, and to do that, because we didn't have control logic or a control PCB, there was actually an engineer under that table playing puppet master. So it was a well-rehearsed act, and it came off really nicely. So that piqued their interest, and they said, yeah, why not, go for it. Although no heads of agreement signed at this stage, it was just, I guess, a wink and a nod, and we like what you're doing, keep showing us more. So from this point onward, this is roundabout where I came into the company and picked up this project. So I guess in demonstrating our proof of concept to Nespresso, they had one sort of, I guess, sticking point, and they come from a culture where the majority of their coffee is consumed without milk. So Italy, for example, only 15%. Now these statistics have probably changed quite a bit as well, because these are I deliberately put these in from the time of when this project was getting up and going. So in Italy, only 15% of beverages are milky. In Switzerland, 28% of beverages contain milk, and that might be the cafe crema or the latte macchiato. In the US, it was 65 and rising, and in Australia, 85%. I think we have kind of crafted the cafe latte to the point where it's now only a latte. Where, you know, it's a cafe latte, but we just call it a latte. And I'm from Melbourne. If you went into a couple of the old school Italian cafes that go back to the 50s and 60s and ask for a latte, they'll just give you a cup of warm milk. They still insist on you calling it a cafe latte, which is kind of fun and embarrassing at the same time. The next phase was to convince our partners that microphone really is the future. They still had a little bit of reluctance. So all of the people in our, I guess, looking at future projects went on quite a charm offensive. And that was taking our Nespresso friends to some of our favourite cafes in Sydney and exposing them to the quality of coffee that we can get, particularly around the Alexandria office. So these 4 cafes that we have here, which this is just sort of a number of cafes that we use their coffee when we test our machines and have good relationships with. You can see each cafe has its own signature rosette. So, you know, this was a really important part to communicate with Nespresso. And I think what we wanted to do is make something where the difficult part, which is making the milk, make that simple, So then the person who's consuming it and making the beverage can spend their time learning to do the rosettes and then just enjoying the coffee, rather than, spending time burning milk and making bad froth and experiencing bad coffee. So, we wanted to make it as simple as possible. And then also in the United States, at the time, some cafes which were starting to really go down the path of third wave coffee. We exposed these also to Nespresso. So, and then I think some might really notice that there's a bit of an Australian content in there as well in these new coffee houses. So it worked, and they gave us the green light, which was awesome. So now we have to think about, okay, what are the big ticket tasks at this point in the project? What are the two main things to really sort of jump into it? And that was, one, improve the texturing system. So this original system that we used based on the 980 was really good, but it did have a few issues that we needed to iron out. A couple of those were, the steam one was very thick. It had a lot of components in there, and because of the large diameter of that steam one, it did affect the way that the milk moved in the jug. Over time, as you used it, even with cleaning, the holes for the steam and air to pass through would slowly start to change diameter. They would lock up a little bit. So we needed to work out a way to prevent those from slowly filling up and eventually blocking, which required a full disassembly of the steam tip and a very good clean. And we also knew that the venturi, which is this component here, was good, but it wasn't running to its full capacity. We needed to make some adjustments and improve the performance of that. So the engineer that I was working with at the time, he had so many great ideas. He worked on the 980, which was an absolute bonus. And he started investigating things like, okay, so what if we mix the air into the steam more completely? He had a hunch that maybe that had something to do with the controllability of the milk foam. So I think a limitation the 980 had was we had a range of milk between about 4 millimetres and I think 12 millimetres of foam thickness once it had settled out. And we wanted more than that. And we needed more than that to also satisfy the needs of Nespresso. So in this top animation, it might be a little hard to see. I'll just start again. You can see air being injected into the steam, and then it goes through there and it starts red, and then it mixes up and becomes that light green at the end, which means it's fully mixed. So that was an interesting little idea. And it had to be done in a way that didn't create back pressure and reduce the flow. So that was one aspect. Another thought that Dan and I worked on was, what if we get rid of the steam wand altogether? Because that seems to be the blocker here. So we went down the path of designing a steam wand or a steam jug that had the nozzle built into it. And that had the benefit of creating a massive vortex that we could control very simply by steam pressure. So on the right here, this is a prototype that we built. At the moment, that's just steam in there. You can see how much power that's steam and how quickly it's moving around. So Dan's just turning it off, and we're just putting water in at this stage. And then we'll start it up again, and you can see the vortex that it's creating and how quickly it's moving. And then we'll just pan over in a second. What Dan's holding in his right hand is basically a controller which dials down the steam pressure or raises the steam pressure. So that allows us to more or less vigorously mix the steam and the air and change the volume of the steam. So that was a really cool innovation. And we went through the whole process of patenting that. And we put that in front of our friends at Nespresso. We thought it was okay, but they came back to us and said, it's got to have a steam one. This is all about the romance of making coffee. So we had to sort of, that was awesome exploration. And it's kind of great working in a company where we can go down those paths, and if they don't pay off, it's not the end of the world. We just kind of pick up and start doing it again. So then we sort of went down the process of, let's go back to the steam one. All right. So in that process, and with those CFD models, we spent a lot of time modeling and mapping how the steam would operate and what we needed to do. And we got it so far, but we knew that we needed some expert help. So we brought in a professor of fluid dynamics, and we provided all of our modeling to our professor, and he politely took it, and he got back to us a couple of days later and said, it's pretty interesting, but I don't think that the science and the algorithms for this sort of modeling is really there yet. So I don't use it. What I would like to get is some samples of your current steam wand, and I'll pick them up and do some quantitative testing. So he built these funny little contraptions here for measuring back pressure on the steam wand. And then when he sent us these pictures, we thought it was quite cute. We sent him one of our Oracle machines to drive it, but he said, oh, I don't have enough consistent steam. The boiler is a bit small for that. So I decided to hook it up to my locomotive. I guess being a professor in fluid dynamics meant that on the weekends you build quarter-scale steam locomotives. And he had quite a few. This was just the largest one he had that's in the background of this image. And he could just run the thing for an hour or so and just make small tweaks to various elements and see how those that performance changed. So steam pressure and controlling whether more air or less air, everything like that. So through that work, we completely redesigned Venturi, which is that third image at the bottom. And that was a complete redesign of the acceleration area and then the deceleration cone, which probably improved us Venturi by 60 to 70%. So that gave us some really good confidence to then go down to the next step and build our own rig. So we built a new standalone steamer using bits and pieces from other Breville machines. We printed our own PCB. I think there's a Raspberry Pi sort of hidden inside there as well. And Dan wrote some code to get the thing to all drive. So this was the first standalone, first generation of this new style of steamer. And we built that and we tested it. And, you know, we got some pretty good results. So through a lot of messing around and a lot of kind of hair pulled out and just long hours in the office, we ran it and we created 8 steps in the milk foam from 1 millimeter at the top on the left to about 30, 35 millimeters thick of foam at the bottom right, which was absolutely perfect because we needed to satisfy the desire to make the latte macchiato. So that's the image on the left, which is just coffee added into the milk. So you steam the milk in the jug, put it into the glass, and then you add the coffee on top of that, which is the opposite to making a cafe latte, where you start with coffee in the glass and then pour it in. And as the coffee goes in, the milk is denser and cooler than the coffee. The coffee goes in, mixes with a bit of the milk, but because it's less dense and hotter, it sits on top of the milk. And then the foam separates out on the top as well because it's got very little mass in it, mostly full of air. So we knew that we could also create the latte macchiato. So that was that first phase. We knew we were onto something, and it was doable. The next part was where does this new product fit into the design language of Breville? You know, we're working with a company that has an iconic design itself, and Breville had built a very, very strong design language. So we needed to somehow fit it in there. So, you know, let's go back to the Venn diagram. It's an awesome way to work out how we're going to do things. So we had lists of the sorts of details that Nespresso had. You know, the things can be jewelry-like. They're small, they're slim, they're textured, they have geometric, strong, simple geometric shapes. The water tanks are typically external. The touch points feel really quite expensive and they're very nice to touch. And on the Breville side, we have a very strong sort of stoic language in our coffee machine. And we have some design cues in there that are distinctly Breville, like the chamfer and the bouche on the control panel. Also around the feet area, all of our machines sit at the same height, and we have a very similar foot design, only deviating to make it specific to the product. So we needed to work out where we were coming from and where we needed to go to, and that was a pretty complicated and time-consuming task. What we also needed to work out is what sort of platform are we going to design for. And Nespresso had multiple coffee platforms for the way their capsules work. And for want of a better one, we chose what's called the Nespresso U. And that was a very simple design. It had a little trapdoor that you slide open and then close, and then everything happened automatically, and it seemed like a good way to go. It had a water tank at the back that could be swiveled through 170 degrees, so you could shorten the depth of the machine. So that was something that we thought, hey, that's quite interesting. Let's start designing down that part. Let's look at a standalone steamer that could be paired with an existing Nespresso coffee machine, or it could be paired with a new Breville design Nespresso machine, or maybe down the track we might even do a really skinny portafilter style coffee machine, which is like one of our other machines. So it could be these two different options or three different options. So the whole sketching part started looking at some of the signatures that Breville might have, or Nespresso. So the ring pull, the chamfers, or for lifting the steam wand, a paddle type of arrangement. You know, it was really just very early days. Also working alongside sketching, getting into foam mock-ups, just really basic ones, not being precious about them. And this particular foam mock-up was purely just to work out how big is this thing? How small can we get away with? And at this stage, we've decided that it also has to have its own water tank. Earlier on, we were looking at borrowing the water tank from the coffee unit, but that became more and more complicated to do. It also would mean that Nespresso would need to make some modifications, which was an unlikely thing because it was, you know, starting to make demands on the way they manufacture. So this was the first foam mock-up, just having a look at how big, and it had to be big enough to hold a milk jug and for it not to fall off. But it also needed to nestle in amongst the machine, so it took a relatively small footprint. That was something that was highly regarded from what we'd sort of learned through all of our research. Small compact machines for people who don't want large coffee machines like all of our other machines in the kitchen. So that helped focus the design again, and these we're starting to pull together how it might actually start to look, and starting to Also starting to bring a bit more Nespresso into the design language here. If we're going to sit next to a U, let's have a little bit more of the look of the U in there. So if someone had one of those previously, they would still consider buying our steamer and putting it next to it. Again, more foam mock-ups. So the very first one, it's all hand done and thrown together very quickly, just using sandpaper and a knife. The centre one is sort of a combination of doing it by hand, but then starting to add some rapid prototype plastic parts to add sort of finer, better detail. And then the last one, at this point, we were starting to work in CAD and building some CAD models. So it just seemed natural and very quick to CNC cut components out and to print parts and then glue them together and then try different things. And what I did with this particular one is I would build a couple of different spouts and a couple of different steam wand ideas, and you could remove them and replace them, like sort of like a Muppet Monster factory where you could pull things apart and put them back on and just sort of see how different components looked together. So moving on from that, that last foam model, that is what informs our first working sample for this project. Now that it was starting to become a real thing. It was still speculative. We hadn't yet signed an absolute watertight agreement with Nespresso, but they were encouraging us, and you know we were taking their feedback on board and working towards building this machine. So the image on the left is the chassis, PCB, and everything's contained within that aluminium box. And then on the right, you can start to see the panels going on. These were built in a way that was specific to the rapid prototype. It's not how we would have gone into production, but it was really just to make sure we could get everything in there and the machine would run. So on the left is the final product for this design, and it was a beautiful little paired machine. On the left, the full working prototype. On the right was just a visual model. We didn't think that we needed to go down the path of making a working one because we were using known components. And the aim of that one, in fact, was to reskin the U and raise it a little bit. So we didn't want to have to do any development to that. It was a matter of we would purchase the chassis and electronics and all of those components and then put a new skin on it. So it would match our machine. And I have a little video of one of the first times we ran it. So you can see there we're getting the vortex going. That was certainly an area that we needed to improve at this point. And you can see there's still some large bubbles forming on the top, which is a result of the milk not spinning as efficiently as we'd like it to. And you can see I pull out a little zip tie and it does its purge, and that blows any milk and froth out of the tip so it doesn't clog up. And then Dan is putting together a nice cafe latte, and just very casually done. Now, what you can see here is how well it is integrated. You can see, I hope you can see the cascading effect of the milk bubbles rising to the surface. So it looks like a waterfall going down, but it is in fact milk bubbles rising upwards. And you'll notice that the milk foam at the top, that layer slowly gets thicker and thicker. And that takes about a minute and 20 seconds, which is a fairly good sign that it's good milk foam. And then also the glossiness of the milk on top and the pretty crisp delineation between the coloured milk and the non-coloured milk also shows that milk's pretty good. I think it's probably, if I was to make a guess, maybe about 50% as good as a human would do it at this point. But we knew the structure of the machine was good. Now it was a matter of tuning the algorithm and the way in which the air was introduced and the steam and how fast we spin it. And also modifying the angle of the steam wand, and just tiny little finite things. So lots of tuning and adjusted. So we showed this in Nespresso. It was packed up and sent off to Switzerland and taken to their head office in Lausanne, and they loved it. It was really, it performed exactly as required. Neither Dan or I were there. We sent it off with all of the grown-up people. So we had to make sure it worked perfectly because they weren't going to be able to try and tune it or do anything when they got there, and it had to go through all the bumps and crashes of international flight. It worked great, although there were two stumbling blocks out of that meeting. One, Nespresso had found that the U wasn't that good a seller. People weren't taking to it as much as they expected, and the understanding of that was it's too remote, it's too automatic. It had a motorized brew unit. So on the left is the top part, and you can see this is the trapdoor that slides open, which you just push with your finger. It's on a spring that resists you opening it, but then it accelerates and opens itself. So it has a double bias on it, and then you put the capsule in and close it, give it a little push, and then it closes the rest of the way on its own. And then from that point onwards, it automatically does the extraction. Now it was complex. It had a few issues, I believe, with reliability, but primarily the thoughts were that it doesn't engage the user in making coffee. So they wanted us to change to a different style of brew unit, which had a lever on it, and that was fine. We were good with that. And the other aspect, so this is the new one here, and then the other aspect was Creatista liked this double approach. They nicknamed it the perfect match, but again, it was what they were trying to express in this machine was something like a traditional espresso machine. So it had coffee and steam in the same unit. So it was literally back to the drawing board. We had the technology pretty much tuned in, but now we needed to redesign the look and feel of the product. So again, back to the drawing board. So re-sketching, starting off, when you've spent probably 6 months in a very Nespresso mindset. Also, another thing that they asked us to do is we don't want it to look like an espresso product. We want it to have the lever like an espresso product, but other than that lever, we want it to be absolutely Breville. That's why we want you on board, because we love the way your things look, and we know that there are people out there who want capsule coffee, and they want a machine that's different to either the DeLonghi or the Nespresso look. So please go down that path. So it's a matter of exercising the, I guess, the design cues that you've been working on, and moving away from the Nespresso and starting to bring it back into a Breville sort of language, bringing back in the facets, bringing in the Breville buttons, and moving along, working in foam. So there was a lot of to and fro. So working foam, working sketch, back and forth, sketch on the foam, and then go that way. And then we started to hone in on where we were headed. So we knew that we wanted something that probably had some sort of a flat face, and then, like in a way, the E61 coffee machines, which are those very traditional big shiny group heads that came out the front that you put the portafilter onto. We wanted to in some way emulate that. So we started adding these sorts of cantilevered cylinders or spheres out the front of the coffee machine. So we had a very shiny splashback with these very shiny, really beautiful shiny objects that reflected everything around them, and then a drip tray below that. So this was probably the first concept that we were satisfied with, to the point that we would make a foam model of it and paint it up, and then sort of use it as a, poke some holes in it, see what we need to change. We went along through here. It happened very quickly, but then all of a sudden we built a beautiful aluminium block model of it, and then thought, hey, why don't we, use it to create a nice little promotional video that we can then send to Switzerland and say, hey guys, since we've been over visiting you, let's do this. So this machine, we started thinking about, okay, tall cups. We can put in tall cups by removing half of the drip flat tray. But we need to bring a regular espresso cup close to the spout, which is an espresso requirement. The cap, this is the new brew unit with the lever. It has a TFT that pokes out the middle. And it also has a coffee spout that is a little bit like that on a portafilter, so you can see the coffee flowing out. We felt that that's a really sort of special part of making coffee, is watching it happen. We did a whole lot more smoke and mirrors. The reason that's such a tight shot is there's actually a different coffee machine out the back with a long tube connecting through to that to make it appear to work. This machine does not work at all. It's just a block model. So we produced that and sent that off. And again, they came back and said, we really like the combo. So from that moment onwards, the product was known as Combo. No longer perfect match, but we moved into Combo. And it actually stuck with the machine right up until launch. And we had to keep telling ourselves, it's the Creatista, not the Combo, because we were so used to referring to it in that way. All right, so the block model turned into a full mechanical model with some design updates. The previous machine, I might just go back, it has very slab-sided front, but in the process of doing that, I guess there's never a time when we stop developing the way something looks at Breville. We just push it and push it and push it. And an interesting and quite humorous interaction we had with Nespresso early on was the person who was starting to lead this project from the Nespresso side said to our design and innovation director from memory, Richard Hall, where's your design freeze? Because we'd spoken about our process and they'd spoken about their process. So where's the design freeze? And I distinctly remember the answer being the words to the effect of, well, sometimes it might be as late as pre-production. At that point, eyes and jaws fell onto the floor and we almost had to reconvene because Nespresso are very systemized and they have a lot of checks and balances they need to go through to get to the end. And it shows in the product. It's super efficient and it's super lean. We, on the other hand, we want to maintain the creative possibilities. So we, even in this project, I think we retooled a significant part just prior to the first PP. And as a result, we did a second pre-production run because we had some ideas and they needed to be prosecuted. And it made the product better. So the feedback from Nespresso when we showed them the video, and we also took this model over for another visit, was the split drip tray. Nice, but we don't think it's good for us. We don't like the idea of putting a cup or some container into the drip tray where dirt normally is trapped. Even if it's clean at the time, they just didn't like the psychology of doing that. And the other one was the coffee spout. So you can see the coffee flowing, and we love that. But we also knew that over time, that will build up the oils from coffee and it will need to be washed. So we designed it so that coffee spout could be removed and then washed. And Nespresso came back and politely said, well, your machine has a removable coffee spout because you say it might need to be washed. None of our machines have removable coffee spouts. We don't want people thinking, oh, should I be washing the coffee spout of the machine that I have that I can't remove the coffee spout of? So you need to redesign your coffee spout so it doesn't need to be washed. So we lost that little innovation as well, but that's okay. It's worth trying these things and just seeing how they flow, I think. So from that first showing of the first combo, further design work needed. In building that first one, we found ourselves that there were a few structural issues that we couldn't continue with that form factor and size. So unsplit the drip tray, remove the visible coffee spout. The centre line brew unit mechanism, we needed to move that to the side because we couldn't successfully maintain coffee temperature as the coffee came out of the brew unit and then through the spout. It had a longer path. Also, the TFT was too small. We found that it didn't really do justice to the sorts of graphics that we wanted to show. So the picture on the right, we moved that lever to the left. We were able to get a much bigger TFT. You can see the change that we made with the spout. So the outlet of the spout is now hidden, like all other coffee machines from Nespresso. And the machine actually grew to be a little bit larger, probably about 20%. We just needed more space. I think as a designer, I always default to let's make it as small as possible, and if it grows when it needs to, we'll let it. I don't think I've ever been able to build it bigger and then go, oh, we could save some volume there and make it smaller. I'm not sure if we've ever had the time to do that. So it grew. It still looks small compared to other coffee machines, and I think it actually suits its size as well. It grew into the shape and size that it needed to be. So these two images here are the final aesthetic. So previous, that one there, that is what we call the working sample 1. And then this one here is the working sample 4. So I think this is probably, working sample 1 was built in April, and working sample 4 was built around about November, getting ready for a tool release deadline of December. And then tool fabrication beginning in January. So this was the final iteration, and it's, I think, definitely the most refined version. It's got a great cup shelf that retracts into the machine. It has a capsule bucket up here, which holds 10 capsules. It has all of the right heights from spout to cup. We can get an Nespresso travel mug in there by removing the drip tray, which was a requirement. And an interesting thing with the planning on these is if your capsule bucket holds 10 capsules, you need to have enough water in the reservoir to make 10 lungo coffees. Or for our example, if it holds 10 capsules, it needs to have enough water to make 10 lungo coffees and steam 10 maximum quantity of milk as well. So the more milk you steam, the more water you use in that process. And then the drip tray had to hold enough overflow water from the purging and coffee extraction process to again equal 10. So the idea being when you need to replace capsules, or when you need to empty the capsules out of the bucket, you need to fill the water reservoir, and you can also, if you want to do it that way, empty out the drip tray. So it's a time thing. You only have to do that maintenance if you want to, once every so often. Although I do recommend cleaning the drip tray every time you use it. So working sample 4 was the end result for the aesthetics. What I have here is a whole bunch of different working samples, from working sample 2 to working sample 4 in a less aesthetic outcome. And this was purely to test all of the driving mechanisms of this product. And I turned the sound off because it's just wild and confusing, but it's kind of a little bit like what it's like working with our manufacturing partners when we produce it. There's so much energy in the room. There's so many people in the room. Everyone's doing something. It's a little bit like this. There'll be a couple of working samples and there'll be groups of people pulling things apart and testing and tuning. So if I just call out some of these little AVIs, the one which is third from the right on the bottom row, that is testing how many capsules fit into the capsule bucket. And if we try and stuff more capsules in, will it jam? So in this case, it was way past the standard 10 and the possible 12. I think I managed to get something like 18 in total. And that meant putting a stick down the top and jamming it in. That wasn't my idea. I was warned about that, but some people had been known to do it. Oh, I just can't really get round to emptying it now, so I'll just tamp it down a little bit and get one more coffee. You can see the coffee flowing on the far left, which was the idea that we unfortunately had to move away from, but that's fine. In the middle, there's the removable cup support. Now, initially that couldn't be removed from the coffee machine, but very late, I think Christmas Eve, actually, I was sitting at the kitchen table redesigning that because Nespresso said, we need to have that removed. People need to be able to clean it. And we don't want dirt being trapped inside there. So that middle far right is the result of that, where you can get in there with a sponge and wipe out the moving surfaces to keep it operating efficiently. Another important one is the middle far left. When you let go of the steam wand, it goes down in a controlled manner. You don't want it to bounce. It's all about making really robust, solid, consistent touch points. And that, I guess that's the primary thing. Everything has to be consistent. It has to do the same thing, more or less, time after time after time. Also, to get to here, there was a huge push from engineering. So the designers doing CAD models and making things look pretty and making mechanisms. But there was also, and it's far less sort of visually attractive work, there was hour upon hour of Thomas, who was my engineering partner at this point in the project. He spent hours and hours tuning the coffee extraction because Nespresso had a very specific and very demanding criteria that they consider to be good coffee. So as an example, the coffee that's being made in this one, and this would be a working sample 2, to still have that particular coffee outlet, that's a rubbish coffee. That's no good. That would not pass Nespresso's hurdles. And these machines, each time we built a working sample, they were taken to Switzerland, and Thomas would be with the engineers in Switzerland, and they would be going through a whole host of very specific tests. Okay, so this is, I think this is a working sample 4, or it's at least 3, and this is just before we were getting ready for tool sign off, and this is the coffee outcome for this. So we had it back in the office, back in the coffee. One of the aspects, this is one such operation. So you can choose cafe latte. Just turn that down. You can choose cafe latte, and it extracts the coffee, automatically starts the milk, and then when the milk is ready, it's eventually. Now you can see the motion in there. You can see those larger bubbles being crunched down, which is something I mentioned at the very beginning. You can see the way the milk's moving around. We got quite good kinetic energy out of that steam. Okay, so it's coming to an end. It has a soft wind down, so we don't create rogue bubbles. This is the purge, so it flushes water through the thermocoil or thermojet in this iteration, and also runs water through to make sure that there's no milk caught up inside the steam line. And then I think we get the coffee over there, and there we have it. And you can see, well, I hope you can see again the level of the milk that's cascading there, which again is really good. It's also worth noting that halfway through this project, we took on a brand new heating system, which is the thermojet, and that completely revolutionized this machine. It reduced weight, it reduced materials, and it increased performance. It meant that when you turn the machine on, within 3 seconds, the machine's ready to run. Unlike all of the other machines that are out there where you turn the machine on and you've got about 7 to 10 seconds before it starts extracting the coffee for you. And you don't need to purge that heating element before you do the steam, because there's so little mass in it. As soon as you introduce water, it's down to its operating temperature, and then it brings up to either steam or hot water. So finally, I just thought, for those who are not familiar with the machine, this is a nice little video that we put together for the Australian Design Awards back in 2017. And it just shows off all of the different features of the machine. And this is the sort of milking microphone milk that we can produce out of this machine. Now, although we don't, so I certainly as a designer don't design things to get into awards, it's really nice when you do. And I included the picture on the left because that was for the red dot, which we were super lucky to win an award for. I remember when that came in and I got the notification you've won an award, and I said to Richard, hey, we've won an award. That's pretty good, isn't it? And he goes, yeah. So, and I said, but I don't really know what the award is. It said it's the best of the best or something. I'm not really quite sure what that means. And he started to reply, well, it's probably the best coffee machine out of all the ones submitted. So that was a huge win. And, you know, I put this picture in really to sort of show the core team that was working on it. That's who we were. And then we were that and some more, because we had a few members who left the company to go on to do their own thing. But, you know, it's a massive team effort. It couldn't have been done with just Thomas and I. We had project managers, we had people doing finance, you know, we had all of the years of design advice from Richard Hoare. We had Phil McKnight, who was our coffee expert, and, you know, he always says if it's not right, he'll let us know pretty bluntly. So it was, you know, an exciting project for two people to work on, because there were dozens of us in the band. So that brings me to the end.
Thank you, Nicholas. I think we can all clap you virtually. We can send claps from here, actually. Yes, we can. Thank you. Thank you so much for this amazing story. So we do have time to ask questions. Please put your questions into the chat. And I can see 2 questions already. I'll start reading them. The first one from Owen Subali, he says, is this a retro style?
I don't know if I would say it was retro style. It was, I guess, some people see a retro style in the machines that we do design. I think what we try and design is a visual language that has an authentic connection to espresso machines. But we're very forward-looking in our technology, and I think we pay homage to the past, but it's certainly, looking forward and moving forward in the way we design.
Yeah, and I just have a comment. It's funny to see how the prototypes, they look nothing like the final the final thing. They look quite complex. So Nicholas, there's another question here from Min Kong, and she says, "Hi Nicholas, it's like we are back in our sprint review. A wonderful prezzo on one of my fave Breville coffee machines. I was late to the prezzo, so you might have explained this already, but I'm interested in your design process. How do you think your training as a sculptor influenced you as an industrial designer, especially in form and detail explorations?"
I'm not sure if I can put a tangible answer to that. I don't know whether my background in sculpture has informed my the way of thinking when I develop, or whether I do it just because I was a sculptor. And I think that's because I'm very hands-on. From the get-go in this project, I was doing paper craft to work out mechanisms. I would much rather get in and work with my hands than go to CAD, and even sometimes draw. Sticky tape, cardboard, carpet lint, whatever it takes, chewing gum, glue tack, whatever it takes to start creating the shapes and the forms. I guess physical form is just something that I like to look at and push around. So I don't think sculpture informs the way I work as an industrial designer. I think it's just part of me being an industrial designer or previously a sculptor. It's kind of, I guess, a non-answer. It's hard to put. I think an outside person might give a better understanding of how and why.
And there's a second part to her question. She says, "I imagine the controlled creativity, industrial design with DFM limitations and customer needs quite different to sculpture work, but also imagine a lot of crossover when it comes to creating harmonious language and something beautiful."
Yeah.
I guess Nick, just to elaborate a little bit, I guess my question is more centered around, how do you guess, obviously we have DFM limitations and there is, obviously, consumer requirements, and how do you, I guess, combine all of that together and then still create something harmonious? Because obviously if you look at your, products that you designed, they are set apart from, I guess, just industrial design need trained designers, where sometimes the design details are overlooked because, it's not very important to them or whatever. But if you look at sculptors, they're very antsy about, very restless over details and, the whole overall language and how harmonious it is. And I find that very important in creating everyday products that someone's going to be looking at or using it every day, So just interested how you, I guess, resolve all of that.
Maybe from the beginning, I completely ignored DFM. I think of it purely as form. And then I try and work out how it could be made. Is it a plastic part? Is it a metal part? But from the very beginning, I would start with pure form. And I really like the restrictions placed on me by briefs. And DFM is a brief. If it's going to be an injection molded part, there's a brief in there. You have a nominal wall section and it can't be too big because of cycle times. And then you've got your secondary wall sections, and that's in relation to the material and the nominal wall thickness. So that's the brief. So you take the pure bit of creativity and then you apply that brief to it. And that's kind of where, I think that's where the black magic really starts to happen. As a sculptor, and I think why I didn't continue on as a sculptor is you wrote your own briefs, and I think I might have been intrinsically lazy, and my briefs were too slack. So I could do whatever I wanted, and then I just didn't know what to do. So the bringing in of that structure actually gave me the power to come up with an idea and make it real.
Yeah, I enjoyed that aspect as well, the challenges. Thanks, Nick. Good to see you again.
Nice to see you again. Yeah.
So Nicholas, another question now from Adam Barlow, and he says, what an awesome overview of a technology-led product development. What was the development time for the product, and what would you change if you could have your time again?
Okay. I guess, so this was, we did this project in about 12 to 14 months. But it really took years. So the very beginning of the project before I was on it, I think started back in 2012 or even 2011. And then I picked it up, as I said, it was the 1st of July when I started at Breville in 2013. And then I worked on it with Dan and then with Thomas all the way up until April of 15. And that's when we actually had a head of agreement signed. Although all the way through it was like, okay, we need to launch it in a year, we need to launch it in a year, but those years kind of stepped along until we'd made our agreements with Nespresso. And then as soon as we hit April, it's like, right, this has to be launched in November 16. So we're now in April 15 and we have to launch it just a little bit over a year later, which means it has to be mass manufactured, you know, about 12 months down the track to make it happen. So all of a sudden it went from a very sort of languid sort of creative process to, right, now we have to actually make this thing real. And we had to turn on the turbochargers. And we certainly wouldn't have done it if we hadn't had such a great manufacturing partner who basically said, right, we can do that. You guys need to spend a lot of time at the factory with us, helping us, but it's totally possible. So I guess that would be one thing that would be nice to do again is not to have it so rushed. I think from April until December, mid-December, I spent 2 months, two weeks out of every month in China, working with our manufacturing partners, doing this. So I'd do 2 weeks and come back for 2 weeks and go for 2 weeks and come back for 2 weeks, which was awesome fun. Loved it. But it starts to wear down a little bit after a while, all the flying. When flying feels like catching a bus, you need to stop.
Yes, Nicholas, I'm very mindful about the time, and it was an amazing presentation. Thank you so much. You know what I will do? There's 6 more questions. I will send them to you and via email, get your answers and put them in LinkedIn, release them in LinkedIn so that we are mindful of everybody's time. So yes, a heartfelt thank you to you, Nicholas, for sharing generously this story, and also to all our attendees. Thank you for joining us and making the evening even more special. And stay tuned for the details and the invitation to the next talk, which will happen on the 11th of April. But until then, stay safe and well. And goodbye, everyone. Thank you very much for attending.
Thank you, everyone.
Thanks again, Nicholas.
Thank you.
Thanks.